So hi guys, welcome back to my channel. So this is going to be the second part of the solid principle video. The first part is already uploaded in my channel. You can watch it if you haven't. In that video I have explained SOL of the solid principles, and in this video I'll be explaining the I and D part. I part, which I feel is the bit theoretical. It is not very big, it is not very vast, but I feel that the D, dependency inversion principle, is something that is very important, which I feel. Okay, so now without wasting ado, we can directly head towards the principle. So starting with the interface segregation principle, you all can see the definition that client should not be forced to depend on interfaces they do not use. Okay, so again repeating the definition, client should not be forced to depend on interfaces they do not use. Okay, so if a class is forced to implement the methods it does not need, the design is already broken. Okay, so what it is trying to say, that let's say I have created an interface I. Okay, it is having, okay, let me change the color of the pen. Okay, so let's say I have declared an interface A, it is having method A1 and A2. Okay, so A1 and A2 does the work related to A. Okay, now there is a class which is known as C1. So I am implementing, that is implementing A. So what interface gives the power is, if you are implementing any interface, then you must have to implement all the methods which is declared inside an interface, or we can say that you must need to override the method which is declared inside the interface. So okay, so that is fine that I have implemented A1, that is and also I have implemented A2. But what if this C, which is nothing but a class, is do not have any relation to do with A2, but still I need to implement this method. So this principle is all about removing the dependency on the interface, or we can say that making the interface so precise that the class which is implementing that interface does not have to implement the method which the class does not care about. Okay, so I hope this is clear. Moving to this, why ISP even exists. Okay, so as I have explained you with an example, that we are eliminating the overhead of the class to implement the unnecessary methods which is coming from the interface. So why ISP exists is, interfaces grow with time. That is true. So interfaces grow with time. Every new requirement adds a new method. Existing classes are forced to implement the junk. This is the all about this principle. Okay, and you get unsupported operation exception. Okay, so now ISP is all about precision. Precise interface means in an interface it should have only methods that is related to that interface functionality only. Okay, precise responsibilities and precise dependencies. So this is all about ISP. Okay, so with the help of UML example, we can understand that what is the problem that ISP solves. Okay, so now here is the machine, and machine is having three methods. Now simple printer implements the machine, and it must have to scan, it must have to fax, but simple printer does not need to care about scanning and faxing. Simple printer only prints. Okay, so I haven't shown here implementing the print, but in the code example I'll be showing. Okay, this is just a example. Multifunction printer. So for this multifunction printer, it is obvious that it will be implementing scan also, it will be implementing fax also, and it will be implementing print also. But the problem occurs when simple printer, which does not need to care about these two methods, have to implement this scan and fax. Okay, so by using the ISP, how we have segregated is, so I have created three interfaces, which is nothing but printer, scanner and fax. So all the methods which is related to the interface are in their own respective interfaces. Okay, so now simple printer now will only implement this printer, and in the first part, as I have explained the difference between the abstract methods and interfaces, when to choose what, that also I have explained. So on that video I have explained that a class can implement any number of interfaces. Okay, so this multi-factor printer, because this prints also, scan also and fax also, but in this example I have implemented only these two, so it can implement fax, it can implement scan, so this is working fine. Now with the help of ISP, we have achieved that whatever class cares about the method, they can implement that interface and override that method. No overhead of implementing the unnecessary methods. Okay, so now let's move directly to the code and see the code example. So you can see here that not following the interface segregation principle. So I have created one interface machine which is having three methods, and now created, okay, so now created one multifunction printer which is implementing the machine, and now just because it is implementing the machine, we need to override all the three methods, which is okay for multifunction printer. But what about simple printer? Simple printer implemented machine and need to override these three methods, but scan is not supported, unsupported operation exception. Fax is not supported, so unsupported operation exception. This is just a business logic. So I have explained you that why ISP exists is you get unsupported operation exception if you don't follow this principle. Okay, so this is the method. What it is doing, it is taking the interface machine and it is printing the print, fax and scan. Okay, so what I have done, I've created the machine interface reference which is pointing to the multifunction printer, okay, and pass the function printer inside the process. I've created the machine interface reference and pointing that reference to the object of class simple printer and passing that simple printer inside that process. Now if I'll run this as we are expected that, so okay, so let's see the output, which is nothing but multifunction printing, that is okay, multifunction printer scanning, that is also okay, multifunction printer faxing, that is also okay. So now the problem here occur is simple printer printing till printing it is okay because printing is simple printer printing. Now moving to the scan and fax, it throws the unsupported operation exception, scan not supported. Okay, here it thrown exception. So this is the exception that we are talking about, that if you do not use the ISP, then you need to handle it with throwing an exception that this method is not related to the class. Okay, so now moving to the part where it follows the interface segregation principle. Okay, so let me comment it. Okay, so now we can see here that I have created three interfaces, which is nothing but printer, scanner and fax. Okay, so now multifunction printer has implemented printer because it print also, it scans also and it fax also. So I have implemented three methods: print, scan and fax. Now simple printer, it only perform the printing, so I have implemented the printer. So just because I have only implemented the printer, it is only overriding the print function, okay, or print method. Okay, so now simple printer printing. Now what I have done, I have created the three methods which in turns is taking printer, scanner and fax. Okay, so now what I have done here, I have created a class and its object and also simple printer class and object, and in the process printer I am passing this class. Now you have a question that why here we are taking the printer interface and here we are passing the class object. So why, how it is working? So in the first part, as I have already explained how this is working by explaining you the, I guess in the third principle, while I was explaining the third principle, I have explained why it is working. So I'll be explaining here also. So it is okay to pass here the class which is implementing this interface. I'm repeating again. Okay, so it is okay to pass the class which is implementing this interface. Okay, so why? Multifunction, which is a class, we can pass it inside this because multifunction is implementing the printer. I hope this is clear. So MFP I have passed inside the printer. Now second thing, process scan, scanner, again I have passed this MFP. So again repeating, I can pass the class which is implementing this interface. Okay, so in process scan I have passed the MFP is implementing the scanner. Now third part, I can pass fax also. So in the fax also I have passed MFP, and if you'll run this, and also simple printer SP I have done only process print SP. Okay, so process print, this is the printer. Okay, so simple printer is implementing the printer, so I can pass the process printer SP. Okay, so I hope this is clear. Let me run this, and if you'll run, you'll see that multifunction printer printing, multifunction printer scanning and multifunction printer faxing, and here for the simple printer it is only printing. So we have achieved our desired goal with the help of interface segregation principle, and this is it. This is all about the interface segregation principle. So let's move to the last principle of the solid principle. So it is dependency inversion principle. Okay, so now let's start with the definition of this, and we'll be heading towards what actually this principle try to say, and I feel that this principle is very important. So in the upcoming videos, when I'll be posting the patterns of the LLD, you will be observing that there is a very frequent use of all these principles. Okay, let's start with the definition. I'll be explaining these definitions for you all. I have written the code here itself, and in the Eclipse also I'll be showing by running the code. So the reason behind writing the code here is so that I can explain it in a better way. Okay, and I'll be running the code in the Eclipse too. Okay, so now let's start with the definition. Okay, so what DIP is trying to say is high level modules should not depend on low level modules. Instead, they both should depend on abstraction. Okay, so I can feel that this definition is lacking somewhat clarification. So let me read the definition again. So high level modules should not depend on low level modules. Instead, both should depend on abstraction. High level modules should not depend on low level modules. Okay, instead they both should depend on abstraction. Is it clear? Let's see now. Abstraction should not depend on the details. Abstraction should not depend on the details. Okay, details should depend on abstraction. Let's see one by one what is high level modules, what is low level modules, what is abstraction. So first, high level modules. Okay, so it contains a business rule or code logic. It decides what the system, not how it is done. Okay, repeating again, it contains the business rule or code logic. Wherever we can find the business logic, we can consider it as a high level module. Coming to the low level modules, it contains implementation details. It decides how something is done. Okay, so wherever the implementation is defined that okay, this method what it is trying to do, we can consider the class it as low level modules. Okay, brutal but accurate rule. If business requirement changes, high level changes. If technology changes, means the implementation changes, low level changes. This is the one stop rule for high level and low level. Now both should depends on abstraction. What it actually means, business logic, which is nothing but the high level, should depends on interface, which is nothing but the abstraction. Implementation code, which is nothing but the low level, should also depend on the same interface, which is nothing but the abstraction. Here business logic high level depends on abstraction. Database vendor implementation depends on abstraction, which is nothing but interface. Now coming to the final definition of dependency inversion principle. This you can consider it as the interview definition. So now dependency inversion principle ensures that high level business modules are not tightly coupled to low level implementation. Means high level should not directly depend on low level. Otherwise it will be considered as tightly coupled. By making both depend on abstraction, high level should depend on abstraction, low level should also depend on abstraction. This improves flexibility, testability and maintainability of the system. Okay, I hope till here it is clear. Now with the code example, I'll be showing here, I'll be clearing some of the points here and also will be running in the Eclipse. Okay, so let's start with the point where the code which is not following the dependency inversion principle. So this class I have considered it as low level module. Okay, so now what it is doing, Razorpay gateway, it is declaring one method which is nothing but an instance method. It is having a implementation how charge is being done, keeping an implementation how things are done. So that's why it is considered as low level module. Okay, so charging via Razorpay. High level module, this contains the business logic. Okay, so now inside the payment service, what I have done, I have created the class and its object, declaring or deciding the object through the constructor of this payment service. And what I have done, this gateway I am pointing to the Razorpay gateway. Okay, Razorpay gateway. Here only I can see, or you all can observe that I have made this code as tightly coupled. Okay, why tightly coupled? Because let's say some more other examples came in future that instead of Razorpay, I want to pay it with the Stripe, then I'll be creating one more class. That is okay. I'll be creating one more class. I'll be declaring this charge. That is still okay. But the main high level module again needs to be changed because the gateway I'm pointing to Razorpay. In case in future, let's say some Stripe came, again I want to do the changes and pointing that gateway to the Stripe. Okay, so here I have made it as tightly coupled without using that dependency inversion principle. Now I have declared one method which is nothing but void pay. Okay, what it is doing, gateway dot charge. It is pointing to the method this charge. So I hope this is clear. So public static void main, inside that what I have created is high level module, its object pointing to payment service, which is nothing out of the box. This is simple class and its object. Now service.pay means payment service dot pay. Okay, what it is doing, it has created another class. Okay, it has created another class gateway dot charge, which is nothing but Razorpay gateway dot charge, which in turn will print this charging via Razorpay. But there is a lot of problems here. Payment service, which is the high level module, depends on the Razorpay gateway, which is the low level module, which is not the correct implementation. What rule is violated? High level module depends on the low level module. In the starting only, I have explained with the definition that high level module should not depend on the low level modules. Instead, both should depend on the abstraction. But here abstraction itself is missing. So this is not the good code example. This code is tightly coupled. This code has missing abstraction and many more things. Okay. So now let's move to the point where dependency inversion principle is getting followed. Okay. So the first point here we can see this is the abstraction. Okay. Now I have created one interface payment gateway. Okay. So void charge. Okay. Low level module. Why? Because the implementation of charge is being here. So it is considered as low level module. So Razorpay gateway implements payment gateway. Now I am overriding this method charge by printing that charging via Razorpay. Nothing magical, nothing out of the box. Created a class, implements that, override this method. Done. Just for your information, I have uploaded the first part of this video, solid principle, in which there is a detailed explanation of these three principles. Okay, starting from the difference between abstract class, what is interfaces, what power they holds, in what scenarios you need to go with abstract classes, interfaces, what are the rules, what is composition, and many more. With the help of code example, with the help of theory, each and every word is explained in very detail. So if you haven't watched, you can go and check out that video. Now moving toward the high level module, which is nothing but a payment service. This is the business logic that I am doing. Okay, so again I have created an interface payment gateway. Okay, this is an interface, not this. So this is the constructor which intake payment gateway and will initialize the object. Okay, here gateway, and dynamically what we'll be doing, gateway dot charge, because I have told you that in future, let's say I introduced, instead of Razorpay gateway, I'll introduce the Stripe gateway, so it should handle. Okay, so that's why I am not hard coding that class, which I am doing here, that Razorpay gateway. This hard coding I am not doing. Okay, so this way I have eliminated the tightly coupled, I have made it loosely coupled. Because in future, let's say Razorpay gateway, instead of Razorpay gateway, some Stripe gateway came, so the object will be passed here and it will be assigned to gateway, and respective gateway.charge will be called. So I hope this is clear till here. If you have any confusion regarding this part, I'll genuinely suggest you to watch the first part of the video, and after that it will be very clear. Now the calling method. So what I'm doing here, payment gateway is equal to new Razorpay gateway. By the way, I'll be explaining it with the code, and there also you will be clear about all these explanations. Okay, so payment gateway is equal to new Razorpay gateway. So what I've done here, let me explain you. So this is the interface reference, which is pointing to the object of the class. Okay, let me repeat it again. This is the interface reference which is pointing to the object of a class, and because now this gateway is containing the pointing to the object of the class, I can pass it here. Okay, in the while creating the payment service class. Okay, so what will happen? So payment service is equal to new payment service gateway, which is nothing but Razorpay gateway. Okay, so what it will do? It will call the constructor of the payment service. Inside this, it will get dynamically it will get the object of Razorpay gateway, just because this reference, Razorpay is implementing this interface, we can pass the class object here. That I have done here. That just because Razorpay gateway is implementing this payment gateway, I can pass this gateway here. Okay, so now I have passed here. Okay, so this gateway, now it is pointing to Razorpay gateway. So now what I have done here, service.pay, payment service dot pay. Okay, so what it will do, Razorpay, by the way, till this point of time, this gateway is pointing to Razorpay gateway. Razorpay gateway.charge, it will print charging via Razorpay. So in future, if we want to introduce, as I have already told, that there is one more payment method, Stripe Pay. I will be declaring one this Stripe Pay and will be calling that pay, and it will correctly call that method. Now here what I have done, payment service is a high level, Razorpay gateway is a low level, payment gateway is an abstraction. You can see here, payment gateway is an abstraction, Razorpay gateway is a low level, and payment service is a high level. So with this way, by following the dependency inversion principle, we have achieved the loosely coupling of the code. Okay, so now let's move to the code example. Okay, so with the code example also you will be clear. So now what I have done, by not following the dependency inversion principle, this is the simple Razorpay gateway. Okay, it has one instance method charging via Razorpay. Okay, this is another method, by the way. This is the low level module, this is the high level module, because this contains the business logic, this contains the implementation. Okay, there is no abstraction missing, there is no abstraction which is missing here. Okay, so private Razorpay gateway, okay, which is nothing but a class. Through the constructor, I am initializing the Razorpay gateway. At this point of time only, you all have observed that I have made this as tightly coupled. Gateway.charge I am calling. It is sure that it always call this method, even if we want to try, or even if in future if we want to introduce some other methods, it's not possible. We need to change this. Okay, and I already have explained you in the third principle, open close principle. That's why I'm like requesting you, if you haven't watched, you can go and watch the first part of this solid principle. So now moving towards Razorpay gateway class, payment service class, it is calling the gateway.charge, which is nothing but charge via Razorpay. What I've done, in the payment service, I have created a payment service which is nothing out of the box. This is simple. Payment service.make payment, I have called payment service.make payment. It will be calling. So what it will be doing, it will be printing the charging via Razorpay. Simple. Payment service.make payment. Payment service.make payment. What it will do, gateway.charge. Gateway is nothing but Razorpay gateway. Razorpay gateway.charge, charging via Razorpay. I hope this is clear. Now moving towards the code which is following the dependency inversion principle. Now this is the example of code which is following the dependency principle. Why? This is the payment gateway, which is nothing but the abstraction. This is the Razorpay gateway, which is nothing but the low level module. Okay, this is what abstraction, this is what low level module, this is high level module. Okay, this is the abstraction. What I was frequently telling when I was explaining the not following dependency inversion principle is, let's say in future if you want to implement the Stripe gateway, how I'll be implementing. So in this example I'll be explaining that how we have expanded our code. Okay, so now payment service, payment gateway. Okay, so let's start. Payment gateway, which is nothing but an abstraction. Razorpay gateway, which is implementing the payment gateway. It is implementing the method charge. Stripe gateway, which is implementing the payment gateway, overriding this method charge, charging via Stripe, charging via Razorpay. This is the high level module, declared the interface payment gateway, and dynamically through the constructor I'll be getting the interface reference, which in turn will be pointing to some of the objects of these, either Razorpay gateway or Stripe gateway. So this dot gateway will be equal to gateway. Now void make payment. Here I'll be getting the reference of an interface, which in turn will be pointing to some of the object of this, and in the runtime it will decide gateway.charge. Either if I'll be passing the interface reference which is pointing to Stripe gateway, then the charge of Stripe gateway will be called. If I'll be passing the interface reference which is pointing to Razorpay gateway, then that Razorpay gateway charge will be called. I hope this is clear. Now let's say the calling method. Okay, this is the following principle. Okay, so now I have created one payment gateway which is nothing but Razorpay gateway. This is the interface which is pointing to the class which is implementing this payment gateway. I'll be repeating once more. This is nothing but the interface reference which is pointing to the class object which is implementing payment gateway. What I have told, this is nothing but a reference, interface reference. This is nothing but a interface reference which is pointing to the class which is implementing this interface, which is pointing to the class which is implementing this interface. Okay, So Razorpay, same thing which I have done with Stripe. Interface reference, which is pointing to the class object which is implementing this payment gateway. Done. Now, payment service, I have created this high level module object. Okay. And with the help of payment service 1, dynamically, as I have, when I was explaining this payment gateway, I'll be getting the interface reference which will be pointing to Razorpay gateway. I'll be passing the interface reference which will be pointing to Razorpay gateway class object. I hope this is clear. I'll be pointing to, I'll be passing the payment, I'll be passing the interface reference which will be pointing to the class which is implementing this interface. So I passed here. So what it will print? For the first time it will go Razorpay gateway. Razorpay gateway, it will be assigned to gateway with the help of this, or we haven't passed it in the constructor. So in the make payment, it will dynamically check that what Razorpay reference is pointing to, Razorpay gateway. Okay, so call the Razorpay gateway charge method. So it will call charging via Razorpay. While passing the Stripe, it will check that what reference is pointing to. So it is pointing to Stripe gateway class object. Stripe gateway class object. So it will be printing charging via Stripe. Let me call this. So you all can see here the output, which is charging via Razorpay, charging via Stripe Pay. Now, if I want to introduce one more, okay, so what I'll be doing? Class, okay. So same thing, system.out.println, same thing, charging via, I'll be doing PhonePe. Now, what I'll be doing? No, nothing, no, like I don't need to touch this, okay. What I'll be doing here? I'll be just doing payment service 1 dot make payment, and I'll be passing the PhonePe. Before that, I need to initialize this also now. Payment PhonePe is equals to new. Now what I have done, I have created one more class which is implementing this payment gateway, overrided this charge and passed it inside the make payment. Now if I'll do run, so you all can see here that there are 3 outputs charging via PhonePe. So this way I have written the code which is loosely coupled, and I have achieved the dependency inversion principle. So this is all about this principle, and I hope this is clear, because this payment service is not directly depending on the low level module. This payment service is not directly depending on the low level module. Instead, it is depending on the interface. Okay, so here interface is the mediator. Okay, so this way we have achieved this thing. Payment service is depending on payment gateway. Razorpay gateway is depending on payment gateway. We can tell here also one more thing, that let's say here PhonePe, something called gateway, that for just for the naming convention. This is also the low level. It is also depending on the abstraction. So with this way we have achieved that. High level depending on abstraction, low level depending on abstraction. There is no direct connection. Okay, so this is all about the video. So I hope this explanation makes this principle clear, or I can say the crystal clear. So thank you for watching and being patient, and from now onwards I'll be posting the design patterns. So thank you so much guys for having patience. So thank you.